Okay, now we will discuss about the mechanism of centrifugal pump. Okay, here we show you the common mechanism, the common parts in centrifugal pump. So a few label here is the main part in centrifugal pump. So from here, I hope first student could draw this drawing. At least you could draw this sketch in exam, because this is the common structure, the common part for centrifugal pump. And then all the terms here, especially the I. So, and then we have the impeller here. So, and then we have casing here. So we have volute here, and we have outlet here. Please make sure that you could label your schematic sketch exactly like this diagram. So this is very important. They will give you a lot of marks in test 2 and also the final. Okay, please make sure that you could draw a schematic sketch like this one. Okay, so here, so this is the maybe side view, and this is might be the front view. The normally the typical front view of this is front view of centrifugal pump, and this is the side view for the centrifugal pump. Okay, so here you could see that the inlet flow is horizontal, and then the flow will flow through the blade here. So, and then it changed the direction into the vertical direction, because it changed the direction from horizontal to vertical. So we will call it as a radial flow, or the radial centrifugal pump. Okay, so this is the common one. Okay, so we go back to our side view here. Okay, so as I said just now, the water will flow. The inlet is coming like this one. So means it comes at the center of the blade. So this is the blade. Okay. So if we see from the side view here, okay, so we found that the water will come from the middle here, from the center point here. So we call this point where the inlet water comes in. So we call this area is an I, EYE, an I. So, and then, so water will flow here. So, and then water will enter the into the blade here. So, and then maybe you're quite surprised because there are no labeling for blade. So they call it as impeller. So what is the difference between impeller and blades? Okay, so these parts actually, okay, if we look it into a 3D part, so it will become like this. So we have a blade here in 3D. So, and then this blade is actually stick. Okay, okay, this is another blade, for example. Okay, one part of this is called blade. Okay, however, so in assemble the centrifugal pump, the manufacturer not manufacture this one as one single blade. It is actually attached or molded into a disc like this one. So I think I have a picture of this. Okay, this is something like this. Okay, if you could see this. So this is the blade. However, this blade is actually attached at these two discs. Okay, so it's okay. Okay, so can you see it? So this is the blade. Here is the blade. Here is the blade. So the blade is inside this structure. So however, so this blade is actually attached at this casing, at this plate. So we have the upper plate and we have the lower blade here, the lower disc here. Okay, so the total of this one, if you could see here, so this is the vane. Vane mean blade. So this is the blade. Okay, and then this blade is actually attached at these two discs. So these two Ds is called the shroud. So we have the front shroud and then we have the back shroud. Okay, and then the total of this one mean the shroud plus the vane or shroud plus the blade is called the impeller. So we have the impeller here. So mean the impeller here is actually the total part of this one. Yeah, I hope you could understand this one, because maybe when you read a lot of books, you get confused. Some people call a shroud, some people there is word of shroud, there were word of vane, they are talking about impeller and so on. So I would like you to make it clear here. So in this one, when we call it the impeller, mean it is actually the set of blade here, and then the housing here, the disc that attach the blade. So that is the impeller. Okay, so the impeller is the important parts, because water from the eye here will flow through will flow on the blade here. Okay, so and then the kinetic energy will be transferred, and then water will centrifuge. Please remember why we call this centrifugal pump, because they are centrifuge force. So when it's rotate, when the impeller here rotates at certain speed, so they will create centrifuge force. So this centrifuge force will push water go outside the impeller. So when water go outside the impeller, so water will enter the volute. Okay, so means that you could imagine. Okay, just remove this. Okay, you just imagine when water here comes out, so it will be touched, it will be carried, it will be rotated by the impeller here. Okay, and then at certain moment, so the water will being thrown out like this. So and then because it already has momentum, so the water will flow into the volute here, and then it will go outside this one. Okay, I hope you could imagine the mechanism, how water being transferred or what happened inside a pump. Okay, so and then the structure of volute here. So volute here means the structure for this one to this one until this area. So if you see the picture here, you will find that the area is different. So it is a small cross-section area of volute at top here, but the cross-section area will become bigger at the bottom. So it is purposely designed like this. Why? Because when the centrifuge force comes in, so it will throw the water here. So now the water will have high energy. So and then if the so means water will have a certain amount of flow rate. Okay, so you have about Q is equal to AV. So what happens if the cross-sectional area here is small? So means we have a higher velocity. So and then what happened to the pressure? So if the velocity is higher, so the pressure is lower. The pressure is lower. So and then at this cross-section area, again, we will evaluate by using Q times AV. So at this area, the area is higher. So means that the velocity is now lower. So what happened to the pressure? So according to the Bernoulli equation, if the velocity is lower, so we will have a higher pressure. So here, so we are purposely create this design. At the end here, the volute cross-sectional area will have a larger cross-sectional area, because we want to make sure that the pressure is high. By reducing the velocity, so the pressure is become high, and then when the pressure is higher, so it could go to the upper level. Okay, so means that if you need to explain about the structure of a centrifugal pump, okay, please make sure that you could explain about the design of volute, because this is the most important point when you explaining the centrifugal pump. Okay, so and then the impeller is mounted on a shaft and it's often driven by an electric motor. The casing include the suction and discharge nozzle and houses the impeller assembly. The portion of the casing surrounded the impeller is termed the volute. Liquid enters through the suction nozzle to the impeller eyes and travel along the shroud, developing a rotary motion due to the impeller vanes. Okay, another thing is, okay, here in centrifugal pump, okay, because we design to make sure we have high pressure, it is mean that the casing here is very important. As you know, if they are leaking in the casing here, so it will reduce the pressure. When the pressure is bit lower, so means that your pump is doesn't have good efficiency. So means that in centrifugal pump, so the casing here is very important. You must make sure there are no leaking in the casing. So and then this is the idea, as I said, the radial flow, the mixed flow. So and then normally we are in our syllabus we are talking about the radial. So means that the inlet flow will flow in horizontally like this, and then we assume that the outflow will flow out vertically like this one. So this is the, as I said previously, the idea of shroud and the idea of vanes. In certain textbook, they will use the vane here, and in certain textbook, they also use the word blade. Okay, we will see this one later on. So here, I hope you could imagine the structure of centrifugal pump. So the most easily to confuse is about the shroud, the vane, the impeller, and also the blade. So there is actually a structure, a complete structure of vane and impeller. So this is the real picture of centrifugal pump, as we could see here. So this is the inlet. So you will attach this one into your pipeline. So the water will comes in, and this is the motor. So and then normally you will have a very good seal here. So means to make sure that there are no water leaking that could damage the motor. So and then it will give a centrifuge force, and then the water here will go out at high pressure. So the high pressure here can be converted into high velocity, or it could move to the higher place.